What's up, guys? Happy Monday. Today, your lesson, continuing obviously ratio and rates, but how we can take what we've been learning about ratio and rates and apply them to different types of problems. We did equivalent ratios and rates on Friday, and that is going to carry over into what we're doing today. So, our first type of problem here, if you take a look, we've got 4 over 7 is equal to m over 35. Now, don't freak out. Technically, this is algebra, but I want you to pretend that this m is just a blank space, right? If the fraction 4 over 7 was equal to another fraction of something over 35, our job would be to try and figure out what that number right there would be if these fractions were equivalent. Now, we have to take what we know about equivalent fractions to try and figure out what that answer would be. So, for example, we could say simplify 4/7 and simplify this. Well, that's going to work because we don't know what this number is. So what we're going to do is very similar to what we did with ratio tables in that lesson. And we're going to try to figure out what we would do to get from the numbers that we know, which are the denominators, what we would do to get from one denominator to the next. And in this case, 7 times 5 is 35. And then if we did the same thing to the top, we know now that multiplying the top and bottom of a fraction by the same thing gives you an equivalent fraction. So if we multiplied 4/7 by 5 on top and 5 on bottom, then it will give us an equivalent fraction right here. Now we already know the bottom is 35. That's what helps us figure out what we're multiplying by. So if we multiply 4 times 5 on top, then m would be not an m, but a 20. So the answer to this problem right here would be m equals 20, right? That missing number right there would be 20. And that's what we're going to be doing today. And we're going to be using some real world type of problems with it, but that's essentially what we're going to do. So let's take a look at a problem. Heritage Middle School has 150 kids. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school will prefer gel toothpaste. So what we're going to do, okay, is we're going to take students that prefer gel toothpaste to total students, right? So we're going to write this down because this is the ratio, right? Gel toothpaste over total students, right? That's our ratio. That's what we're trying to figure out. Now, what do we know about this ratio? Well, we know in Miss Mason's class, 2 kids prefer gel toothpaste out of 3 kids, right? The kids that prefer gel toothpaste, total students, right? 2 out of 3 students. Now, what we're trying to figure out is how many kids in the total school would prefer gel toothpaste if there were a total of 150 students in the school. So in this case, this is much like the first problem we just did. We're trying to figure out this number right here. So then what we do is we figure out how we would get from the denominator to this denominator, right? How would we get from 3 to 150? And if we did the same thing to the top, that should give us our answer. So how would we get to from 3 to 150? There's a couple different ways to do this. You can divide 150 by 3 to figure out what this is, or you can just kind of think, well, 3 times what would give me 150? You might come to figure out that 3 times 50 would give you 150. So if we did the same thing at the top, then 2 times 50 would be 100. Then we could say that if 2 out of 3 people in Mrs. Mason's class prefer gel toothpaste, then 100 out of 150 in school might prefer gel toothpaste. And that's how we use our ratio rates and equivalent ratios to answer questions like this. Let's try 2 more real quick. I can't see the words on this one. There are 810 calories in 3 scoops of vanilla ice cream. How many calories are there in 7 scoops of ice cream? What we need to do is set up the ratio to figure out what that missing number is. So we need the words first, right? So calories and scoops of ice cream is what we're comparing, right? So let's go calories, scoops. Okay? If we know that there's 810 calories, right? Calories in 3 scoops, then we need to figure out how many calories there are. Calories go up top, and that's what we don't know. How many there are in 7 scoops. So we end up in this position here. Now what we have to do is we need to take 3 and get it to 7. But we did this in ratio tables, and what we found out was that you can't get from 3 to 7, right? 3 times nothing will give you 7. So what we found out in ratio tables was that we could actually set up a table here, right? 8, 10 over 3, and actually take calories and scoops. We can actually take a second step to figure out maybe what way we could get to 7. And I think the best way to do this is to find the unit rate. Instead of finding how many calories are in 3 scoops, let's find out how many calories are in 1 scoop, right? Calories per scoop. And if we can figure that out, then all we have to do is multiply it by 7. So let's divide this down by 3, find a unit rate here, and divide 810 by 3, which is 270. 81 divided by 3 is 27. So 270 calories per scoop. Now that I've got this ratio reduced down to a unit rate, I can then multiply it by 7 to figure out how many calories are in 7 scoops. And 270 times 7, 1,890 calories. Is that correct? I believe so. 1,890 calories would be our missing number here. 1,000. That's a lot of calories in ice cream. So your answer would be 1,890 calories. The next one. While resting, the human takes in about 5 liters of air in 30 seconds. At this rate, how many liters of air does it take in 150 seconds? So we're talking about air in seconds, right? Let's go liters of air. On the bottom, we'll put seconds. So let's go ahead and write down the ratio that we know, right? 5 liters of air in 30 seconds. So 5 over 30. Okay? And what we're trying to figure out is how much air in 150 seconds. So we need to find this missing number here. So the first course of action is to see, is there a way to get from 30 to 150? If not, then we probably need to take it down to unit rate and then multiply back up, like a 2-step, make a ratio table. But in this case, it's kind of nice because 30 will multiply up to 150. 30 times 5 is 150. So we can just multiply the top times 5 and get 25 and find out that the answer is 25 liters of air in 150 seconds. So our job is to find those missing values today, use what we know about equivalent ratios and unit rate even to help us solve these problems. See you guys tomorrow.